AWS User Group. It's great to be talking to you this evening about a topic that's really important to all of us, and that is sustainability. I'm Attree. I'm a solutions architect at AWS with a day-to-day focus with power and utilities customers, but with a heavy interest in sustainability. So with introductions over, let's get into it. Okay, so it's important to note that sustainability touches everyone, and multiple sectors of society have expressed interest in sustainability and using it as a measure for what companies they'll work with, what companies they'll invest in, and what ultimately companies will buy from. And additionally, socially responsible investing or impact investing, along with ESG, environmental, social and governance criteria, they now appear regularly in the media and in investment prospectuses, in annual reports, and interest levels reaching all-time high for sustainability data from companies in 2020. Recent data from Morningstar that showed that global assets in sustainable funds hit $1.25 billion in the third quarter of 2020, which was a record high and has only grown since. So whether it's a company mission statement, whether it's a board directive, whether it's investor pressure or consumer pressure or regulatory pressure, sustainability really is a hot topic at the C-level with many customers that we're working with, and likely your own companies too. So let's get onto something that you're likely already familiar with, and that's the shared responsibility model for security. And you may have seen this before, where AWS is responsible for the security of the cloud, and customers are responsible for the security in the cloud. So for example, AWS is responsible for the physical security of data centers and managed services, and customers are responsible for the network firewall configurations within their VPCs, using managed services and to encrypt them. But this is a sustainability talk, not a security talk. Well, we can apply that same concept of a shared responsibility to sustainability. So if we look at the model on the slide, at the top half of that model, that's the customer responsibility. So that's about making architectural decisions. That's about selecting and using the correct services for the job, and determining which code is running and how efficiently that code is executing. And on the bottom half, on the green part of that diagram, I'll move into it for you, we can see AWS's responsibility of the cloud, of the sustainability of the cloud. And this covers things like the way that AWS designs buildings, designs rooms, designs servers, and takes care of it from construction all the way through to recycling of those assets. It covers the way that AWS purchases the energy and ensure that energy and other resources that we use, such as water for cooling, are used efficiently. And lastly, it covers AWS service teams and how they run the managed services and optimize them for sustainability by increasing or maximizing the overall utilization of the underlying resources that are providing them. But we're not going to be focusing on the sustainability of the cloud in today's talk. We're really going to be looking at sustainability in the cloud and how you as a customer can optimize your own workloads. But to that point, I did want to highlight a few key points on AWS's journey into sustainability. So we've put measures in place to utilize the increasing amounts of renewable energy sources that we're onboarding. We've introduced water conservation practices at certain sites around the world. And we're also producing our AWS ARM processors, so our custom silicon like Graviton, but also our chips like Trainium and Inferentia. And that all contributes towards a lower overall energy utilization. But I want to focus on what customers can do with their responsibility and what information and data, metrics customers need in your hands to make sustainability decisions. So at reInvent, we launched the reInvent just gone. We launched the customer carbon footprint tool. It was announced at reInvent, I should say, and it recently just went GA. And that's available to everyone now, every customer within their billing dashboard. And this information is really good. It's really good for giving us that directly measurable CO2 equivalent of emissions of running our workloads in AWS. That's fantastic. It's really good for reporting, and it's scientifically, methodologically proven data. So we can use that for our audit reports. That's great. And it can give us a really good indication of what to address in our workloads, and especially around region selection. So the pie chart in the middle for my diagram that is on the screen is all blue, mainly because the bulk of the workloads that I have in this account that I grabbed this screenshot from run in EMEA, which is a much greener region for us at the moment in Ireland. I'll explain that in a second. But if you're running workloads across Americas, across EMEA and across APAC, you'll likely find that those workloads in APAC will have a slightly higher CO2 emission number. And that's all down to the energy and carbon intensity of the grids that are powering the data centers on those energy grids. So whilst we can use this data usefully, it shouldn't be considered as the single source of truth for making operational and architectural decisions. Another reason for this is because the data that you'll see in this tool is 3 months delayed. And that's down to the time it takes to collect and process the carbon intensity data from our energy partners. So how can you make more faster decisions on your workloads? Coming back to the region thing and why this one is all blue, it's likely because the workloads that I have in this account are mainly in EU West 1. And EU West 1, that's Ireland, is one of 5 regions where AWS purchases and retires environmental attributes like renewable energy credits and guarantees of origin to cover the non-renewable energy that we use. And the other regions are at US West Oregon, at GovCloud, Europe Frankfurt, Canada, Canada Central I should call out, and Europe Ireland. But we plan on powering our operations with 100% renewable energy by 2025. So now the customer carbon footprint tool is available to you in your own AWS accounts. I encourage you to go and look at them in your own accounts. You'll be able to find those in the billing console. So looking back at the customer responsibility, how can we make workload-based decisions on the topics that are covered? Think about how you do this for security too, or maybe for cost optimization. One might conduct a review on those topics. And a key way of understanding your existing workload and how it fares against best practices is by conducting an AWS well-architected review. Hopefully you've conducted one of these for your workloads already, or you're familiar with well-architected already as well. And at reInvent, Werner, in his keynote, announced this sustainability pillar. So the 6th pillar to be announced as part of the well-architected framework. And that's to complement alongside, so it's not standalone, it's not a lens that we apply, it's a first-class citizen pillar of the well-architected review that sits alongside cost optimization, security, reliability, performance efficiency, and operational excellence. And the sustainability pillar is really there to help you achieve 3 goals, right? It's to understand the impact of those services that you're using. is to quantify those impacts through the entire workload lifecycle and to apply best practices to reduce those impacts. When you apply those best practices, we've broken those best practices down into 5 best practice themes. So we focus on user behavior, software and architecture choices, hardware choices, data, and how and what your development and deployment patterns are for your applications. So the white paper is now available at the link on the slide. The term sustainability is a broad field covering social, economic and environmental aspects. And we focus on environmental aspects in the well-architected pillar, especially energy consumption and efficiency. And it's an important lever that architects have to improve and reduce resource usage. So how can you improve? How can you improve your workloads? Well, the answer really is how you always have, especially with things like the cost and performance efficiency pillars that you might be familiar with. The well-architected pillar for sustainability outlines an iterative process, and it's similar to how customers have been improving for cost or performance for decades, right? You need to be aware of your goals, or at least set them. What are your sustainability goals? And what are your current performance against sustainability KPIs? You might not even have any sustainability KPIs yet, but it's important to set them, and it's important to then use this process to identify the metrics that you're going to need to meet those KPIs. So first of all, set a goal for your company and then look at for all of the workloads that you can optimize. Then you prioritize the workloads by which will have the biggest impact, for which you'll need data and metrics. And those workloads or changes that will be a good investment in terms of time for optimization as well. Next, you can hypothesize, what can you optimize for the workload? Can I change the processor to Graviton? Or can I implement auto-scaling? Does this instance need to be on all of the time? Or can I perform that work as a batch process? Or can I rewrite components in a more efficient language, such as Rust? And those hypotheses then need to be qualified and prioritized by how long they'll take, how much they'll cost, what risks are associated with them, etc. Then you can experiment, measure the impact, roll back if the outcome is not desirable, or deploy the change to production. Then move on to the next hypothesis, iterating through that process as you go. And through working with customers, we found that they're really good at optimization, right? They've been optimizing inside and outside of the cloud for many years. And as long as you can provide a metric to an engineer, they tend to be able to optimize the workload towards that particular metric. But what would be a good metric to optimize for sustainability? Well, there are a few that are useful for optimizations, and we call these proxy metrics. They're aligned broadly around utilization of storage, network, and compute. So cost can also be considered, but it sometimes can be a poor proxy metric for sustainability because of differing pricing models, where a pricing model doesn't necessarily match utilization. So and different pricing models across regions as well. So it wouldn't discriminate, for example, between a really heavily used or really heavily utilized EC2 instance and an idle EC2 instance, for example. So in that case, cost would not be an ideal proxy metric, and perhaps CPU utilization would be a better one. These metrics compete with one another, right? So data transfer and storage compete with one another. Do you go multi-region and then trade off the retransfer of data across those regions for availability as well, and redundancy? Compute and storage might compete with one another. Would you pre-calculate big data aggregates versus recompute them? Compute and data transfer, they would compute with each other as well, around rendering at the edge, for example. So when you select a metric to optimize for, you'll actually be selecting many as they compete with each other. Think about a use case for generating thumbnails for uploaded user content. Maybe you could generate that thumbnail at upload time. And you could then store that thumbnail in storage somewhere. But if that video or content that you're creating that thumbnail for is never requested, then you're storing that thumbnail unnecessarily. And that's taking up space on a storage, on a hard disk somewhere. Or you could generate that thumbnail when the source content is requested. Now that would duplicate the compute work every time that video is or other piece of content is requested, but it minimizes the storage. So you can think about the trade-off in that respect with that use case. Optimizing for these metrics also competes with traditional non-functional requirements, such as availability or data retention policies. An example here would be using an application deployed on EC2 servers across 2 availability zones. If one instance were to fail, your application can be served by the EC2 instance in the second availability zone, therefore keeping availability high. But it trades off utilization, as those 2 instances are unlikely to be running at a high load while still having the capacity to absorb the additional load of the failed instance. So when you're selecting metrics to optimize for sustainability, you also need to be aware of the non-functional requirements of the application or workload and determine where you can make that trade-off. We need to avoid the pitfall of thinking that we're just looking at resources. So when your usage is the same, but your user base is decreasing, that's a cause for alarm. So hence you should factor in your business metrics to measure efficiencies at a resources unit of work level. And that could be something like vCPUs per connected vehicle mile, or megabytes of storage per customer. And that way you can normalize your KPIs to compare them over time to measure your improvements against sustainability or for sustainability. You also need to establish dashboards with KPIs at a team level, so each application team can own their own goals and work on optimizations independently. And this here is just one way to do this. Most of you are already familiar with AWS cost and usage reports. I hope for the sake of cost showbacks. And as the name implies, it's also a great resource also for your usage, to find out what your usage is of resources. And you can combine the cost and usage reports with further metrics from Amazon CloudWatch and business metrics from your company and query them with Amazon Athena. And then you can start to establish a dashboard with a few KPIs in QuickSight. And start with KPIs for which you have a really large influence in the shared responsibility model. So for example, EC2 compute resources, and then experiment based on feedback by application teams. Now, we have customers doing this already, and one of which is Scania, the heavy truck manufacturer. And during an internal hackathon, Scania developed a set of sustainability KPIs to the application level. And the team then worked alongside AWS or with AWS to determine how those KPIs could then be measured through AWS usage reports and service metrics alongside business data. Scania, ultimately, they're looking at creating an efficiency rating for Scania IT solutions to enable the most sustainable IT system possible within the company. And to help customers kick off this process of data collection and analysis, we've developed an AWS well-architected lab, which guides customers through the process of turning those cost and usage reports into efficiency reports. So this lab is live. You can go and see it now on the well-architected lab site and run through it yourself. And And by completing that lab, what you would be doing is collecting usage information through the cost and usage reports. You'll be loading that data into Athena and beginning to query and create proxy metrics for sustainability to create efficiency scores. Those efficiency scores that you could then extrapolate into KPIs or use them as your KPIs. And that lab allows customers to bring your own assumptions for sustainability, as well as some ready-made queries. When I say assumptions, that might be something like you might apply a cleaner score for graviton-based instances or workloads that are heavily reliant on graviton, for example, over workloads that aren't graviton-based, because we know that running graviton EC2 instances have a lower watt performance than other manufacturers of processors on our EC2 platform. Or you might apply a cleaner score for resources that are deployed in one of those 5 regions that I mentioned earlier where we use renewable energy. So understanding what you know about sustainability in the cloud and bringing that to your own workloads through the use of proxy metrics is the key takeaway from that well-architected lab. And I really encourage you to go and have a look at that for yourselves. So as a bit of a call to action for those of you listening, check out the customer carbon footprint tool in your AWS accounts. It's there, the data is available to you to give you a really good indication at a really high level of what to look for and where it might be, where your focus might be directed. I'd then encourage you to go and have a look at the well-architected sustainability pillar and how you can apply that to your workloads, carry out a well-architected review, perhaps, for the sustainability pillar itself. Really identify your workload sustainability goals. So once you perhaps run that well-architected review, understand what it is you want to change. What is it that you want to go after that would have the biggest impact in terms of sustainability? And then use that well-architected lab as that starting point for collecting metrics to help you meet those goals and the KPIs you've set through those goals. And reach out to your AWS team if you need assistance in running through one of those AWS well-architected reviews for sustainability. We're available to help you out. If you want to talk sustainability more generally, reach out to us and we can have those conversations. So thank you for your time this evening. I look forward to answering your questions a little bit later on in the Q&A session. Thanks.
And thanks, Tom, who is joining us right now from, where are you, Tom?
Well, not so sunny Southend today, but yeah.
Southend, lovely. By the sea? Are you actually by the sea there?
Yeah.
Marvelous.
Yeah, by the sea.
Marvellous. Probably nicer at different times of year than this one. Cool. So some good stuff there on sustainability. Now I'm a little cynical about sustainability things in as far as I don't believe that the capitalist system is set up to encourage people to think about spending time and money on solving this problem. Like you mentioned Scania, like what are the types of organisations that you're seeing who are investing that? Because there's obviously no immediate profit gain from saving the environment, right?
Of course, yeah. I think you're right in that I think there are some economic models that may need to change for sustainability on the whole, but we're seeing customers from a broad range of industries work with AWS to further their own sustainability ambitions. Mm-hmm. And whether that's customers that have signed up to the climate pledge, which has reached over 300 signatories this week. Mm-hmm. Across varying sectors, right, from retail to manufacturing to consumer goods. It really comes down to what's the customer, what are those customers' goals? Mm-hmm. What have they signed up to from a regulatory point of view? What are they obligated for from a regulatory point of view? But what have they signed up for from an ambition perspective as well?
Yeah. Yeah, so there's a sort of, I guess there's an increasing number of people talking about this in general. So people be sort of swept up in that and probably invest partly for image, I suppose, in some cases. But if that's what they need to do in order to solve the climate crisis, then let's keep hounding them to do that, right?
Yeah, absolutely. Yeah, I think there is an element of there's definitely a lot more focus on it from board level decision makers that we've seen with customers this year.
Yeah, that's good stuff. So on that journey to generating more sustainability, making workloads more sustainable, I suppose I should say. I guess you as a AWS person have had access to some of this carbon data maybe a little earlier than we have as customers. So you've maybe seen this journey for a little longer. What are the things typically that customers find difficult about? I guess moving to Graviton or taking an application and breaking it down into lambdas, for example, so that it's using less compute. What are the things that tend to be hard?
Yeah, I think the thing that tends to be difficult from an architecture perspective is starting to accept is the acceptance of treating sustainability as a non-functional requirement. So like we have previously with ensuring that we've got the right level of availability, we've got the right level of disaster recovery mechanisms built into an application. Now customers are really starting to think about, okay, how are we building this application in a way in which is sustainable? And one way customers are finding that a bit challenging, as I touched on in the talk, is actually defining that resource unit of work. So what is it that actually the real root of what your application is trying to deliver, right? And whether that is in Scania's example, vCPU hours per connected vehicle mile, which is a great metric for trying to reduce, right? Because if you're reducing the amount of compute that you're doing in the back end for every mile your vehicle travels, it's a really directly measurable metric to reduce. But they can be really difficult to define. And I think Scania had potentially had a bit of an easier ride trying to define that metric. And customers, I think finding it a bit tricky to actually define what those resource unit of works are. But your question about moving to Graviton, we're finding customers are actually finding that journey relatively easy. Especially if they're using languages and libraries that already have compiled binaries for ARM, and they're getting huge efficiency and cost savings from moving to Graviton too. And similarly with Lambda functions being able to switch over to the ARM architecture, pretty much with an API call now. Again, if your code and your dependencies are ARM compatible, of course. There may be a bit of work involved if they're not.
And are you seeing teams, I guess, fairly readily changing language environments? Even like I think I can't remember whether your slides had this, but I've seen recently a sort of league table of language versus efficiency with things like Python and Ruby and like all the things that are really easy to write at the top, and then like Rust right down the bottom using sort of very little CPU power at all. But teams tend to be quite religious about their stack choices, and it can be difficult to sort of move the needle on that. What are you seeing in that sort of landscape?
Yeah, I'm familiar with the report that you're referring to, yeah, it's a big change to make, right? To change your programming language and environment is a big scary change to make, and not one that a lot of customers want to make necessarily, or see the benefit to make that change for. But what I can say to that is that AWS is investing very heavily in Rust at the moment. We're writing a lot of the core components for services in Rust, and when you're changing services to the scale in which AWS is deploying them at, every tiny incremental improvement that you can eke out has a huge cumulative effect over all of the servers that change is deployed to across all of our regions, availability zones, etc. So if we can eke out every single instruction on a or cycle on a CPU or on our servers by changing the programming language to a lower level language like Rust that has a little bit more security than C, we're really starting to see that underlying overall utilization benefit that I touched on in the presentation.
Gotcha. So for organisations like Amazon, it makes sense because of the scale that you're operating at, but maybe it makes less sense for a SaaS vendor or maybe Scania are doing this. I don't know.
I think the answer is always it depends, right? I think it's important to be heads up about new languages whenever or new in the field when it comes up, and when there is evidence to suggest that language can perform faster. It should. I think customers should be cognizant of the benefits that it could bring.
Yeah. The it depends answer, very familiar to me as a consultant. It's the classic answer to all questions in the consultancy realm is it depends. What are you trying to do?
There's trade-offs involved, right?
Of course, yeah. So I'm just going over to the Twitch chat. Ginge Fringe TFT, a first-time chatter, is asking a question that I don't quite follow because I think he pasted that during as you were talking. So Ginge, if you'd like to reframe your question, I guess, so that it makes a bit more sense outside of the context of what Tom was talking about at the time you post, then I will ask him that and we'll get the details. Conatsat22 says, essentially focusing on 5 well-architected pillars where we can have measurable KPIs will indirectly measure the sustainability pillar too, though, won't it? Carbon footprint KPI isn't something that we can all connect to immediately. It must be complex to calculate and understand in a way how much effort is needed to swing that number to some target. It's a good start. I think it was interesting to me, like and my team, as we looked at the new sustainability pillar, how much of it was essentially kind of cherry picked a little bit from other parts of well architected things like reduction of cost in that sort of landscape is likely also to result in greater sustainability because lower cost is probably the result of using fewer things, and there was a lot of kind of relationship with the rest of well architected.
So cost can be a good indicator for sustainability, especially where the cost of the service that you're using is directly tied to the utilization of the service. So something like storage could be a useful one for EBS, for example. If you're using less block storage, you're using less you've provisioned less or fewer megabytes of underlying hardware. Where cost doesn't make sense is like the EC2 example. It doesn't discriminate between a really heavily used EC2 instance and an EC2 instance that's sitting there at 2% idling. So that's where you might want to start looking at other pillars. At other metrics. But there are synergies with the sustainability pillar and the other pillars of the well-architected review. Performance optimization is a key one, right? So if you can optimize your application for performance, but also by doing that, maximizing the utilization of the underlying resources, which also incorporates cost most of the time, you can see where that does start to blend. But I think where the sustainability pillar really puts the focus on it is in those 5 domains of the best practice. I recommend just going to have a look at those, having a read through those 5 domains of the pillar, to how they might apply to your workload. It applies more focus on it for sustainability than might be covered or might not be covered by the other pillars in the well-architected framework. Yeah,
understood. So I guess the other thing that I don't know if you have more details on, but when you're talking about the sustainability metrics for different regions being sort of higher or lower based on kind of how that energy is generated. You mentioned, I think, buying carbon certificates or energy certificates of some sort. Now, is my understanding therefore correct that for many regions, AWS is using non-green, non-renewable energy sources, but sort of offsetting that by sort of some kind of double entry bookkeeping relating to carbon use? Is that how that works right now? And the aim by 2025 is to not do that, because you don't have to, because you're using renewables for everything.
Yeah, so we don't share the energy mix of data, the energy mix data for specific regions. All water in our regions at the moment. There are those 5 regions that I mentioned where, like I say, we do purchase and retire the environmental attributes. So using renewable energy credits and guarantees of origin for renewable energy where we are using that. And that's US West, Oregon, GovCloud, Frankfurt, Canada Central, and Ireland. Amazon's ambitions, this is not AWS, Amazon is on a path to have renewable powered operations by 2025. So that's not just an AWS statement, that's Amazon wide, and that's been brought forward from 2030 as well.
So I guess what you're saying is there's a lot of the information about energy consumption by region is sort of opaque to us as users. We can see sort of relative scoring and some stuff in the tool, but the actual I couldn't, as a user, point at my workload and go, this percentage of this workload is being powered by non-renewable energy sources over this period of time or whatever.
Yeah, we don't go to that level of granularity or detail right now. So the other great source for customers to use to make assumptions about the energy grids that we operate in are the 451 reports that we've had conducted independently, which show the benefit of moving to the cloud, which shows an 80% energy carbon saving from moving to the cloud from running on premises. And there's 3 reports. One was done for the Americas region, one for Europe, and one for APAC. And essentially there's 3 because the carbon makeup of the grids in those regions is very different. So depending on where you're using the cloud or operating a workload, or where your users are based, is very dependent on the intensity of the energy that's going to be coming in.
Right, and so in which of those regions, off the top of your head, obviously, is there the most difference in moving from on-prem to cloud in terms of sustainability and energy mix?
Off the top of my head, I wouldn't be able to recall.
Okay,
I have to get back to you on that one.
Sure. Yeah, no, just kind of interesting. I guess if you're selling the benefits of the cloud, but those benefits vary greatly across regions, it's sort of interesting to look at the comparison. Sorry to put you on the spot. That's that's what the Q&A session is sometimes for. So you're a solutions architect within AWS. You're working with power and utilities. What's exciting to you at the moment? What are you what was great to see it reinvent? What are you hoping to see I guess later in the year? What will help your customers the most?
Yeah, I think what's really exciting to me at the moment is the proliferation of new renewable energy sources on the grid, especially within the UK. Right, so onboarding brand new wind farms, brand new solar cells, or solar arrays, as well as the concept of prosumers that have solar on their roof, maybe a Tesla Powerwall as well. But the challenges that brings in terms of demand and in terms of production load is actually quite a challenge for the infrastructure to be able to manage the frequency, to keep the frequency correct. So from an AWS point of view, I'm really excited about some of the IoT data streaming services that we've got coming through to understand where's that load coming from, where do we need to turn things on, where do we need to turn things off, and using the IoT service family of services again to actually make those adjustments to that kit that's in the field. So maybe that's turning a wind farm off. Right. Because we're generating too much power for the demand at the time. So I'm really excited about a lot of that at the moment.
Yeah, sounds good. I guess, a field in which a lot of change is happening, right? In the
Oh,
sort
huge
of
amount.
I've got colleagues who do have solar panels. One who's very sort of up on electric vehicles and all the kind of mechanics of that. It's quite interesting. I'm going to be buying a house in the next year or so, and so that's going to be on my mind. Is like, how can I invest in those sorts of things as we move in order to reduce our impact on the environment as we go forward. So, Tom, thanks for joining us. Are you going to be at the summit in at the end of April?
I will be, yeah. I should be speaking at the summit as well with one of my customers. So have a look out for the power and utilities track, and you might see me on stage.
Great stuff. I will be there. I'm not going to be on stage. I think one of my colleagues is talking about certification. Sandra, who was on this stream last time actually, but maybe we'll get to catch up in person and raise a glass together. Thanks, Tom. Great having you on the stream, and we'll see you again.
Thanks, John.
Cool. Cheers.